Hi everyone. In this today video, I am going to demonstrate the assignment of practical DevOps program of NashTech Global. So in this program, we are going to use the cloud provider AWS. And in this program, we have these following technologies that are shown in the following architecture. So first of all, we have provisioning, which is powered by Terraform. With Terraform, it will help us to create all the resource on the cloud provider, which is AWS right here, without having to interact on the GUI, and we can build up, we can tear them down easily. So in this provisioning, we are going to have VPC, which cover all the following services, include EC2, ECR, and Kubernetes Service, EKS. Second part is the GitHub repository, which going to store the microservices application. And the third part is our CI flow continuous integration. So with the CI flow, we are going to use Jenkins. And this Jenkins, we have a webhook from Git repo to get all the resource from the repo. And we are going to use Docker to build all the source code into images. And from here with Jenkins, it's gonna push all the images to the Elastic Container Registry, stand for ECR right here. Next, we have the ops repo. In this repo, we will only store the manifest files mostly for deployment for services, config map, and potentially some CD files as we coming next. We have continuous deployment, CD flow. In CD flow, we are also gonna use Jenkins. And with Jenkins, we're gonna get the deployment file from the ops repo, and we are going to use the Quebec controller to apply all the manifest file. This will get the images from the Elastic Container Registry, from the CI flow, and then it will deploy the source code to EKS. And the final part, we're gonna have monitoring. So in this monitoring section, we are going to use the Prometheus to get the metric from the application, and Grafana to be a dashboard to visualize all the metrics. And these two will monitor the EKS cluster. And that is the complete flow project. So let's get into demo. Alright, so let's get started. So first of all, we're gonna have to build up the provisioning, which contain all the following services as shown right here. And I already have the Terraform finished. So in here, we're going to have the provider, which is AWS, gonna contain region, server local names. We're gonna have the VPC right here. We'll cover the EC2, ECR, and EKS. We're gonna have the EC2 instance. This one is the EC2 instance right here. That is going to be used for Jenkins and Docker. Some security group and rules to support EC2. And then we'll have the Elastic Container Registry to store all the images that are built by the Jenkins and Docker. And the final part is EKS. We have all the source code right here. We'll build up the cluster with all of the following add-on as of the policy and permission required for the cluster to work properly. and will be under the same VPC as shown in the architecture. Some request management notebook, and we have a role for the elastic block storage to allow the AKS to interact with the EBS right here, and that is the Terraform. Alright, so that is all for the provisioning part right here. So now we are going to build up all of the resources to the cloud provider AWS. So first of all, we're gonna go to the directory of the main file right here, and we're gonna apply the command Terraform init so that it will initialize all the resources needed. And then next, we're gonna use this command Terraform validate to validate all of the syntax and make sure that everything works. And as there's no syntax, no error, we can go ahead and use Terraform plan. This will plan all resources that are going to be created on the cloud provider. And here we have like 66 to add, and yeah, here's all of them. And it shows us. We can double check before creating. And when we are happy with the plan, we can go ahead and apply them with the following command: Terraform apply. I want to add the flag auto approve so that I don't have to confirm it again. It's easy to add. And now it is going to create all the resources on AWS. And before we are able to create all of this, I already have my AWS credential configured. So this is going to take a while, and I'll see you when it is done creating. Okay, so after a while, it is already done creating the whole resources with Terraform. And we can go ahead and check them on the cloud platform. So as earlier that we have seen, we have VPC, EC2, ECR, and EKS created with Terraform. You can go ahead and check them to see if they are created. VPC, EC2, just an elastic container registry. So in the Terraform subcode, I have the name hard-coded with the prefix as Qt Practical DevOps. So with all the resources we created, we'll have this prefix. And we can check. So we have VPC, we'll start with this. The name doesn't look quite right, but that doesn't matter. We have the VPC created. And in EC2, we're gonna have 2 instances. This one is from the cluster. It is automatically created by itself. And then we have the EC2. And here's the cluster, as well as the registry. So that is all set. For the provisioning part, we have them all up and available on AWS. Okay, so right now we already have the whole provisioning up and running. We're going to install some of the tools for the EC2. So we're gonna install Jenkins and Docker first to the EC2. So let's connect to the EC2. See the correct one? Yes. Okay, we're gonna connect to it. Give it a little bit. Okay, the instance is ready for us to use. So we're gonna start installing Jenkins first. All of these commands are already listed down, so I'm just gonna copy and paste most of them. command, apply the yum. I'm gonna install some of the support for the Jenkins itself. It'll take a bit to install. I might skip it until it's done. Alright, so that is done. Now we're gonna install Jenkins finally. Okay, so Jenkins is now done. We're going to enable Jenkins with the command system controller enable to make sure it's enabled and running, and we can start. Okay, so it started. That is, the Jenkins should be up and running right now. But before that, I'm going to install some of the more tools for this to work properly. First of all, I'm going to install Git. We're going to need to use it. And we're going to install Docker for image building. Yes. Alright, so the Docker is already installed. We do the same step, that is start the Docker. Before we can use the Docker, so I'm going to use this following command to add the Jenkins to the Docker group. Otherwise, when we have the image building, it is going to ask for permission and the pipeline will fail. And after Jenkins and Docker install, we will need to install kubectl. I'm going to check to see if it's installed. It is installed. Awesome. And I'm going to install the ham. We're going to use ham a lot for ingress controller and the monitoring. So we're going to need that as well. Okay, now that we have everything installed and all the supported tools for the whole project to run, we can start logging in Jenkins. Using the public IPs and the port we exposed for Jenkins is 8080, we're going to set up Jenkins. We need to do this to catch the password. So I'm going to go back to instance. Sudo cat and the path. It give us the password and copy that, paste it in here, and we are set. And I'm going to install some Success plugin. Click right here. It's able to install all of these, so I'll see you instant. Alright, so now it is done installing some Success plugin. We're going to set up the admin user for Jenkins. I'm going to use my name. Continue. And we're going to use the default URL. And yeah, the Jenkins is all set up. We start using it. But before using, I'm going to install some of the plugin that will help with the pipeline. I'm going to install Kubernetes in the available plugin. Next is EC2. Docker pipeline. ECR. And another tool that I use to purge the history. This tool will reset all the build to number 1 so that it make it look cleaner. So yeah, I have this 5 extra plugin installed and I'm gonna install it. So yeah, after installing, it will restart. To apply all of the plugin, and I'll see you when it's done. Alright, so now it's done restarting. I'm gonna log in again with the credential that I just created earlier. Alright, now all the plugins are installed. We can start using. Before using Jenkins and create pipeline, I'm going to add some of the credentials that we're going to use for the pipeline. Go to this credential, click on the global right here, and we can add credentials. So here, first of all, I'm going to add the GitHub credential. Let's start with username, password. My GitHub username is this one, and my password for the GitHub, I'm gonna give it the GitHub credentials. Make the description empty. So that's the first one. I'm gonna add another credential for AWS. Choose Jenkins. My ID is AWS credentials. You can leave the description empty, and here I'm going to add the key. Create, and yeah, here we have 2 credentials that we're gonna need. So with the credential setup, before we can create pipeline, we will need to set up the GitHub webhook, as we can see in this architecture. I'm gonna set up for both repository, the app repo and the ops repo. So we can go to the repo that we want to connect to Jenkins with the settings and webhook. So we're gonna add a new webhook for the repo. The address will be the Jenkins /GitHub webhook application JSON. We don't need the secret right here, and I only choose the push event. When we save, it will start checking to see if we can push to the Jenkins right here. It will promise if it works by having a check mark right here. It's taking a little while. Yeah, it is good. So I'm gonna do the same for the other repo. And there we go. We have 2 webhooks set up for both repos. Now we can go back to Jenkins and start creating pipeline. gonna click on new item, give it a name. I'm gonna go for an CI pipeline, do the pipeline right here. It's okay. Leave it empty. All of the option will be default. We only check this one. GitHub hook trigger for Git SCM polling. And we scroll down, we're gonna choose pipeline script from SCM. We're gonna choose Git, and we're gonna input the repository repo. So this is the repository for the MSA, the application in here. So we're gonna give it the Git repository address. Credential, I'm gonna choose the one that we created earlier for GitHub. So this is the one. I'm gonna use name, main. This is auto, and this is script part to Jenkins file. So in this repo, I have Jenkins file stored in these two repos, this backend right here and front end. I'm gonna target to there. So first of all, we're gonna target for the front end first. So it's gonna be source, backend, front end, and Jenkins file. And save. So that's first front end pipeline. You can try to see if it works by clicking build now. Hopefully it will work. And we can see all stages on the screen. If nothing goes wrong, they will be all green, and the image will be built and pushed to the Elastic Container registry. While waiting for it to build, I'm gonna go through the code Jenkins file. So we're gonna have all the environment right here. You're gonna target to the AWS credential that we created earlier in Jenkins, and Docker image name. It will clone the repository at first, as we can see. It will build using the Docker file in the repo, and after building, it will be deploying to the registry with registry credential, as you can see. Apply some command to push the Docker, tag the Docker image, and push it to the registry. That is the basic, and it will be the same for the backend. They are technically the same. Okay, so similar it is doing well. So it's done building, and it's gonna deploy image. Alright, so it is done building, and all the stages are all green, so that is good. With how the Jenkins file was created, it should push the image to the registry already. Let's see. Yes, it has right here. Front end. That is awesome. Now we're gonna create the second pipeline for CI, which is for backend. We're gonna do the same step. New item. Front end CI or backend CI pipeline. We can copy it from the already created pipeline right here, so we don't have to set up too much. It's already checked for us. Use the same repository URL, and the only thing I need to change is to change the path right here, backend. It's safe, and hopefully it will work. Alright, we click build now. Alright, so the CI pipeline is built flawlessly, all green. You can check again in this history. So they have both the image now. That is a good sign. So with the CI pipeline run perfectly, we are now going to create the CD pipeline to deploy the application to the cluster. So I'm going to create the same one. I'm going to go with front-end CD pipeline. I'm not going to copy. Okay, so we're going to check it again. Pipeline script, Git, and in this one we're going to use the different repo. The reason is we have two separate repository for application and for operation. So yeah, we're going to target to the second repo, which is the operation repo right here, and I name it as infrastructure. So in here I have the folder called CD pipeline. This is where I store the backend Jenkins file for CD as well as frontend, and we're gonna have the ArgoCD template for deployment and service. Okay, so this is the Jenkins file for the CD pipeline. And it's very simple. In here we just have all the environment variable, restrict credential. You see the one that we already created in the Jenkins earlier. And here we have state, we clone the repository and we deploy using the credential of the AWS. And it will retrieve the access key, secret access from the credential that we choose right here. And after that, it will start connect to the registry with all of the information we put right here. And we'll start doing some command to export of the variable, and it will replace the deployment file and service file. I put it in the ArgoCD template right here. They all have these variable to be replaced. So it's a service. Yeah, so that's the point of this command. And connect, update the cluster context, and it will start lighting both the deployment and service YAML. It is the same for front end, so nothing much to talk about. And that's the Jenkins file for CD pipeline. It's right here. Use same credential. Give it an auto, and we're going to target the pipeline right here, which is CD pipeline backend. Front end first. Save. I'm going to build another item, which is the backend pipeline CD. You can copy it from the CD. Because we didn't change much. Okay, need to change backend right here. Oh, good, save. So we have a front-end CD pipeline up. We can try build now to see if it works. We'll clone the source and then we'll try to deploy to the cluster service. Look like they are green. Alright, so to check if the cluster pod is up and the service is up, we'll need to update the context of cluster. So this will target to EKS, and the region is our current region, US West 2, and the name of the cluster. But when we use this command, we will need to authenticate ourselves. So I'm going to authenticate by typing AWS configure. I'm going to give it the ID. So I'll skip through the credential part because it has sensitive information. Okay, so I already have my AWS credential configured, and I can list right here, and we can see they're all set. So we now can set the cluster context. It is good. We can already check the part. So we have front end running, up and running, because we use the front end pipeline. So I can potentially trigger the CD pipeline for backend as well. Do now. Okay, CD pipeline for backend works perfectly. So it is going to deploy the backend service to the cluster as well. You can probably already check that. Yeah, they're up and running. We can check the service by using this command. And they're all fine. We're gonna need to set up the database as well, but to save time, I didn't create the database pipeline, so we're going to just apply it by hand with kubectl. Some more practice. So with the repo, I already included the MongoDB YAML right here. So we'll apply and build the MongoDB as we apply the manifest file. Okay, so we already have pod, backend, and frontend running. We're gonna need the database for them to run to complete the whole application. So I'm gonna try to apply to build the database with just the manifest file to save time instead of having to create another pipeline for that. So we have the manifest file copied by the Jenkins in their folder. So we can go to there. Let me see. Okay, so after changing directory to the source code that Jenkins copied, we have this MongoDB YAML right here. So I'm just going to apply it with the kubectl command instead of creating another pipeline for it. Apply file MongoDB YAML. It's created. We can check. So in this MongoDB, we have the persistent volume clamp. We can check to see if it's bound. Yes, it's bound perfectly with the permission that we gave. So next, I'm going to install the ingress and Nginx using the ham. With this ingress and Nginx, we can expose it to an ELB address, and we can connect them through the address. So I'm just going to install the ingress with all these following command. Okay, it is done. Now we can check to see if ingress NGX working. It is up and running. We can check the service of it. We have a load balancer IP right here. It's good. I mean, it is working. Now we only have to apply the ingress YAML file. The ingress YAML file is stored in my repository. So this is a little piece of that. And if you want to have a look, go to my repository and it will be linked in the description. Alright, so we're gonna apply the ingress YAML. I gave it a wrong name. Okay, so it is created. We can check. Right now it doesn't buy the arrest yet. It's gonna take a little bit before it can be bound. So we check again soon. Okay, right now it's already bound with the ELB address. You can copy it and see if it works. Copy. It is working. You can try some command hello. Alright, so it is working. You can try a little more. Hi. Yeah, they're added just fine. Now the application is working. We will try to trigger the CI pipeline to see if it detects any changes that we push to the repository. So we're gonna go to this service. I'm gonna try to change the headline right here. Just gonna make change real quick on the console. So I'm gonna give it a new name right here. Update to 1.4. Commit change. So yeah, it is creating pipeline for both front-end and back-end CI because of our configuration. That is fine. Okay, so the CI pipeline for front-end is already done deploying. We can go and trigger the CD pipeline because I didn't really set up for them to run automatically. Go to front-end CD pipeline and manually trigger. Clicking build now. It's done. Try refreshing the application. It might take a little while, but it will be changed. There we go. There's a new change. Make sure everything is working. Hi. There we go. It is still working. And that is the complete flow of the practical DevOps assignment. We have already covered the revisioning, CI/CD pipeline with the Jenkins and Docker, and deployment to the EKS. To get started, we're gonna have to update the cluster context to be able to connect to it. And I already have my AWS credential configured, so we shouldn't have any issue. Alright, so let's try connect to the context. Okay, and let's try to list some of the pod in the file namespace. Yeah, we have all of them, so that means we're already connected to the cluster. Okay, so first we're going to install the Prometheus operator. It will install all of the necessary tools and package. Now we're going to install the Prometheus itself. First, we're gonna create a namespace. I'm using ham right here to install the Prometheus. It has right here, so it will skip. And I'm gonna install the Prometheus with namespace right here, and we'll target to the values YAML file, which we have right here. To apply some of the config for the monitoring, we'll target to the backend with a certain port, and it's already done installing, and we can potentially port forward to see the UI. Okay, we can connect from this. Yeah, we're here. Can connect to Prometheus right now. Next, we're gonna install the Grafana dashboard. This tool will help visualize metric getting from the Prometheus. Oh, it's already done installing. Okay. Above command and the one right here, the same one. We'll install the Grafana on the namespace Grafana, and the admin password is here. Apply the value from this Grafana YAML file. You can find this anywhere on the internet, and it will set a service load balancer, so we can get the service Grafana. It will give us the address to the ELB. In this. So run this command, and gonna give us the external IP to connect to the Grafana dashboard. There we go. So user is admin, and the password we reset earlier is password. You can log in, and we can import the dashboard already. And here we're gonna enter 6417. This will target to the Prometheus of the cluster. Press load. It is default, and we choose Prometheus. We import it. So it should be up and running. This is the time that it's been up, and it has some service right here. Here's some of the service that we install from cluster, front end, coordinates, backend. So we both have Prometheus and Grafana up and running. Now we're gonna try to get a custom metric from Prometheus and see if we can get it visualize on Grafana. So in the backend source code, I have the following code for Prometheus custom metric. Require the ground client right here, and then I have the custom metric, which will count the amount of post requests that come to the application, and we return through this API. That's just the simple metrics. But before that, we will need to apply the service monitor for the backend service, which I have right here. This is a simple piece of YAML file target to the service. Namespace we use default, and then we will target to this path, which matches the parametric in here, then the one in here, target to the backend service. So yeah, you can apply it. Okay, so it is created and we'll try to forward the port to Prometheus. So after forwarding the port, we go to the Prometheus URL and check the service discovery. Right now it should have the backend, which doesn't have before. The target to the API is up and ready. That means it is good to scrap some metrics from the backend. I already have a button to get the API, this API, or the UI, so that we can see it, visualize. So I click right here, get metric. It should give us the 4 right here. So we already see the metric is running from the UI and targets right here. Now let's go to the Grafana dashboard and try to see if we can wrap the whole metric itself. So I'm gonna go to this dashboard and go to explore. So we can type in the metric to see if we can get it. The name I have was number post request hit. Let's see. There we go, we have it. Can run query, and there we go. It is perfect. We have 4 of the requests from the instance. Right here, job is right here. That means the Grafana dashboard can get the custom metric from the Prometheus. So that means they are all working. And that will complete our whole workflow right here for the monitoring. Okay, so that is the end of the basic workflow of the practical DevOps assignment. We have covered everything from provisioning, CI/CD workflow, and monitoring. So now we'll be replacing Jenkins CD with ArgoCD right here. So first of all, we're going to check if the nodes are working. We're gonna create a namespace for ArgoCD. And we're gonna install the ArgoCD with the following command. So that is the ArgoCD install. Let's check, see if it's working. Checking the part of it. Yeah, it is working. Yeah, they're all running. Excellent. So now we try to access the ArgoCD. First of all, we're gonna need to retrieve the password using this following command. Here, where's the password? Okay, so with the password, we will need to use the base64 code to get the actual password. So we're gonna go to base64 code and try to decode this password. This is our password. Now I'm gonna try to forward the port of ArgoCD so that we can access it. Following command. Alright, so we are in. Alright, we can log in using admin and the password that we decoded earlier. Sign in. So we're inside the application. So now we can create the application. And give it a name. And we call it frontend. Name must choose default. Right now for simplicity we choose manual. and we're gonna give it the repository, which is this one, and the path we're gonna give it the path that target the deployment file, which is inside ArgoCD/frontend. Okay, for the path it should be short ArgoCD deploy frontend. It is, yes, seems right. For destination, we're gonna choose the default right here, namespace. I'm gonna leave it as default because I install everything on default namespace. And yeah, everything is normal. Give it as default. Create. Okay, so after finish creating, it will be missing an absent, so we're gonna go ahead and click sync. Everything is default, synchronized. Okay, so now it is healthy and synced. And with the new flow, we are replacing the Jenkins CD with ArgoCD. So I'm gonna go to Jenkins dashboard and disable the two CD pipeline of frontend and backend. Frontend, backend. And here I'm gonna disable project of the frontend CD pipeline. Disable. Yeah, disable right now. And I do the same for backend. Disable. Yeah, that disable. And we're gonna try to push some changes to the repository that will link with ArgoCD and see if it deploys. Let me check the CI. So the front CI build now is 6. We're gonna make some changes. Oh, here's the application. So right now this is what it's like. I'm gonna try to update it to 2. Update it to version 2. And I'm gonna change this one to 6. And let's make a change. And let's make a commit. To our repository. Okay, so with that change, the CI pipeline is going to build a new one. For frontend, we can see right here. Is built successfully, and after committing the result, it doesn't update anything here yet because we have the symbolic as manual, so we're gonna refresh it. There's no change to the application yet, you can see. So we're gonna go ahead and click sync. Everything is default and click synchronize. Let's check the whole flow. You can see it deploy a new pod and it terminated the old pod. And when we refresh our page, we'll see it's updated. And with the ArgoCD deployment right there, we'll wrap up our assignment demo video. Thank you for watching and have a nice day.